Hi, I'm Greg Merck, and welcome to Nordson's online booth at PAC Expo Connects. Thank you for taking the time to join us today. Unfortunately, we can't be together at this year's event, but we are committed to staying connected to our customers and communities. Please use the chat feature to ask questions and share your thoughts. We're excited to tell you more about our best-in-class packaging technologies, and all of us at Nordson look forward to seeing you in person next year. Have a great show.
Hello everyone, my name is Chad Whitaker. I am a Global Product Line Manager with Nordson Corporation. Today we're going to be talking about selecting the right dispense, applicator, or technology for your particular situation. We have a lot of technologies in the packaging space. There's a lot to look at. We're going to narrow that down and show you how to select the right technology for your particular situation.
These are our main packaging module technologies you see here. We have 9 that we're showcasing here today. As these 9 technologies are what we sell most, right? But no, we have others as well. The 6 modules you see on the left are our pneumatically operated modules, meaning compressed air operates them. Our solid blue technology shown here in the top comes in a spring closed on the left and an air closed on the right. Air closed is a bit faster and can handle a wider viscosity range than spring closed. Solid blue is our workhorse technology for low to mid-speed packaging. Solid blue is a ball and seat module. What I mean by ball and seat is that these modules cut off the flow of adhesive by the use of a ball and seat. The vast majority of packaging modules and applicators have this type of ball and seat closure. These modules are about 22 millimeters wide, and it's about a 10 plus millisecond module. So 10 milliseconds dispense is as fast as it can dispense, is about 10 milliseconds. Mini Blue 2 is the industry standard for higher cycle life and higher cycle times. Mini Blue 2 is also a ball and seat module, but it is a few times faster than Solid Blue and can last a few times longer. It also has superior cutoff. It's got the best cutoff in the world. Nothing comes close to Mini Blue 2 cutoff. As customers wish to reduce adhesive usage on packages by stitching or dotting, this is the technology that is targeted. Mini Blue 2 is the technology for mid to high speed packaging, or those applications that require accurate repeatability, long life, or fast speeds. Mini Blue 2 technology is about a 3 millisecond dispense technology. I just showed you the ball and seat modules. Now meet the identical modules, but with incorporated Surebead technology. These modules are used for the same reasons as the ones above that I just explained, but they have active nozzle clearing technology to mitigate nozzle clogs and downtime. We call this technology Surebead. So Surebead technology is active clearing, nozzle clog clearing technology. It comes in needle and seat flavor. All right. For those facilities using adhesives that inherently char or has atmospheric debris in their production environment, such as sugar dust or fiber dust that can enter the systems and cause char, these flavors with Surebead technology can help mitigate downtime and lost production or product due to nozzle clogs. I've reviewed global sales for every ball and seat module we sell over a 12-month period. The customer also buys about 12 nozzles. This tells me they had at minimum 12 nozzle clogs. So a nozzle clog per month on average, that's 12 downtime events for the year due to the nozzle alone. I've reviewed sales of Surebead modules for the same time frame and found those customers only purchased 1.7 nozzles for the same 12 months, which equates to about 1.7 downtime events due to a nozzle clog for the whole year, right? So by these numbers, you're 7 times less likely to have a clog or downtime event with Surebead technology. This quick Surebead animation may drive this point home. So a typical ball and seat module, char comes down, gets stuck in the nozzle. You have a downtime event. You're not dispensing adhesive anymore. You've got to stop the line and fix it. But with Surebead, this operates like a ballpoint pen. It self-cleans each and every cycle. So if that same char finds its way down into the nozzle, that nozzle point simply breaks up that char and dispenses it right out, and you keep running. So this is the beauty of Surebead. Now, on the right, meet our primary electric technologies. These are electrically operated and use no compressed air, zero compressed air. All of these are ball and seat closure. Surebead technology is currently not possible with electrics. Electrics have no dynamic seals, so longer life is typically experienced over pneumatics. However, they do have limited viscosity and temperature ranges. They have a tighter operation window. So the operating window of electrics is just simply smaller than that of pneumatics. And while the majority of packaging facilities around the world choose pneumatic technologies for their applications, there are plenty that choose electric technologies. This is good technology. E400 is our workhorse packaging technology and can do beads or dots of adhesive. E400 technology can be used in slow all the way up to high-speed applications. We find it used across the board. It's primarily found serving carton and case for core food and beverage. E400 is about a 2 millisecond dispense module. EDOT is our dotting technology. So EDOT plus, it's primarily used in confectionery, tobacco, labeling, and other packaging applications requiring small dots at high speed and repeatability, accurate placement of those dots. EDOT is about a 1.5 millisecond module. Sapphire is the fastest electric technology in the world, capable of 1600 hertz burst speed and sub 1 millisecond dispense times. Sapphire finds itself in similar applications as EDOT Plus. However, Sapphire can dispense beads and dots. The window of operation for Sapphire is a bit larger. Sapphire is piezo technology, not electromagnetic like the other electric flavors. Now that you know a little bit about each of these technologies, how do you determine which one is for you? How do we bring this all home and select the right one? I often talk about your recipe, right? Your recipe will help point you into the right module technology. First, we need to determine your material type and application temperature. Most packaging adhesives is in the 250 to 350 Fahrenheit temperature range. What is your adhesive viscosity at your application temperature? If it's above 14 to 1600 centipoise and cutoff is critical for you, say you've got a mid to high speed line and cutoff is critical, you can possibly remove electric from this list. Electrics in thinner adhesives, say sub 1200 centipoise, they can definitely be used in higher viscosities above 1200 centipoise, but cutoff may suffer and stringing may be evident depending on your line speed. So just know that. Calculate your dispense time next. If your target line speed relative to the point of dispense is more than that 10 to 12 millisecond range, then you can likely use any technology. If less, pay attention to number 6. If your required dispense time is in that 3 to 10 millisecond range, then solid blue Surebead is out of the candidate field. But mini blue 2 and electric variants are well within reason. If you need sub 3 millisecond dispense, you have narrowed it down to electrics only. You also have some motivating factors or influencers, such as it might be initial investment may point you in one technology or the other. If you've got a couple of different technologies that can work for your application, these influencers will help drive it home. Another motivating factor may be, if your plant has a push to eliminate air-operated components to reduce air handling costs, then in this case, pneumatics may be frowned upon, even though their air usage is negligible. Let's look at an example. Your cartoner is pumping through 60 cartons per minute. Your adhesive is a standard packaging grade EVA. Your application temperature or set point temperature is 350 degrees F. And at that temperature, the viscosity is 1200 centipoise. So the pattern you need on your carton is a 1/2 inch bead of adhesive. And the carton speed relative to the nozzle or relative to the dispense point is 200 feet per minute. So this all calculates to about a 12 millisecond dispense time. So that 1/2 inch is going to pass under that nozzle, traveling 200 feet per minute in about 12.5 milliseconds. So you've got 12.5 milliseconds to dispense to place that adhesive on your target at that speed that it's traveling. All the technologies will work in this scenario except EDOT Plus. Remember, EDOT Plus does dots well. Beads can be difficult sometimes. Because you are using an EVA, you may be concerned about nozzle clogs, and an influencer may be, hey, I want the Surebead technology to help mitigate nozzle clogs and keep my machine as efficient as possible. So now you have just eliminated the ball and seat flavors of pneumatics, which is solid blue and mini blue 2, ball and seat, and you have also eliminated electrics. you have narrowed the field down to the bottom left, Surebead flavors. So if you have questions on this, drop them in the chat. I'll be glad to answer them afterwards. Let's shake this example up a little bit. Say you changed the adhesive to a 900 centipoise hot melt and you want some adhesive savings. So you cut your usage in half. Instead of a 1/2 inch bead, you're now wanting to put down a 1/4 inch dot, and you increase your line speed. So now the demand on the module is about a 4 millisecond dispense. This new dispense time just eliminated solid blue and Surebead from the mix. Now the technologies in play are electric and mini blue too. If a motivating factor is to eliminate compressed air, then you may want to entertain electric. So whatever your recipe is, please be aware that there's a way to help funnel it down and start eliminating some of these technologies that may not be the right fit for your application. Whatever it is, just get with your local Nordson rep to help you make these decisions. We have top tier global service and support. We serve many customers' needs, providing precision dispensing solutions and maintenance. We have excellent repair and exchange programs along with 24/7 technical support and customer service. We are here to help you achieve efficient production. I want to thank you for giving me your time today. If you have any questions on any of this, please drop them in the chat. I'll be glad to answer.
All right, thanks, gang. All right, some questions. So I've got John asks, why is Surebead technology not possible with electrics? John, I would say it's physical limitation. Electrics have about 1/3 of the stroke as a pneumatic does. So if electric has a 10 to 12 thousandth stroke, pneumatics have a 30 to 35 thousandth stroke. And so when you talk about Surebead cuts off in that orifice from the conical section. So that conical section of the needle comes to a point and it seals or coins on the nozzle to cut off the adhesive flow. Well, to get that conical section fully out of the orifice so adhesive can flow, you have to have, a 20, 25 thousandth stroke or better. Electrics isn't going to give you that. It's going to get that needle partially out of the way, but it's not going to get it enough out of the way so that you can get full delivery flow. So it's just a physical limitation of electrics. You don't have the stroke available to fully get that needle out of its way so adhesive can flow. Next question, Jeremy asks, why is electric cutoff not as good as pneumatic? I'll say in most cases, electric is not going to have the cutoff of pneumatic. So electrics only have a return spring to bring that ball to the seated position. So with pneumatics, you have, if it's a spring close, you have the exact same thing, a spring close. If you have air close, you also have compressed air. So 70, 80, 90 PSI of compressed air that is also bringing that needle with the ball on it to the seated position. So picture a 5-gallon bucket of paint, all right, and you've got a broom stick and you're pushing it through that bucket. You're going to feel some resistance, but not much, right? But if that is thicker, say toothpaste, you're trying to push it through, you feel a lot of resistance. But if you only have 7 pounds pushing through each, one's going to close faster, one's going to close slower, right? Same thing with electrics. Typically, pneumatics can close faster, limiting your tailing or limiting the tailing off of adhesive coming out of your nozzle to limit your angel hair and your stringing. So that's typically why pneumatics cut off better than electrics. Electrics just physically don't have the closing force that pneumatic does. Sandy asks, I have Casey rectors. Can I convert over to Surebead? With Casey rectors and sealers, you typically are using, it depends. I would say the majority of Casey rectors have a shallow back design on their applicator, which is a right angle, and it's probably a dual orifice at that. So most Casey rectors and Casey sealers have a shallow back module. It's typically a solid blue, a ball and seat, and you have right angle dual orifice nozzles. Surebead is only available in single orifice and straight fire only. It cannot shoot 90. It cannot shoot dual orifice or dual stream in any situation. So with that, I would say it's going to depend on what applicator you have on your Casey rector. Most that I see, you cannot. You're limited to ball and seat because they're designed to shoot at 90 degrees and at dual orifice at that. So, all right, again, we're running out of time. Thank you all very much. Be safe in this season. And if I did not get to your question, or if you have additionals that come after the fact, please reach out to me. My contact information is here. Shoot me an email, call me. I'll be happy to discuss anything I can. Thank you. Have a good day.